What is ontological mathematics and how does it shape the world? Find out here today, right now.
All right, so get ready because today we're going to be diving into some seriously heady stuff. Ontological mathematics.
Okay.
Ever heard of it?
How?
It's this wild idea that math, it's not just some tool that we use.
Right.
It's actually like the fabric of reality itself.
Yeah.
And we've got 3 YouTube videos to kind of help us unpack this,
That's true.
each with its own unique spin on this whole thing.
Yeah, that sounds fun.
So we've got From Pawn to Player, which uses this idea to explore personal growth and making better life choices.
Okay.
And then there's Artificially Aware, which takes a broader look at the history of this concept
Right.
and what it could mean for things like consciousness,
Okay.
AI, all big stuff.
Yeah.
And then lastly, we have Sapientia Veritas.
Okay.
And this one goes full-on philosophy nerd,
All right.
bringing in all the heavy hitters like Euler, Descartes, and Leibniz to really dig into the mathematical and philosophical foundations.
Well, yeah, that sounds cool.
Yeah. Let's get into it.
It's going to be a wild ride.
Okay.
So let's just start with that core idea,
Yeah.
math as the ultimate reality.
Right.
Artificially Aware uses this really cool analogy.
Okay.
It says, the universe speaks in numbers, a symphony of mathematical order.
Ooh, that's a cool way to put it.
Yeah, it's pretty poetic.
Yeah.
Right.
Yeah.
So it really gets you thinking, like, what if,
Yeah.
instead of just describing the world with math,
Yeah.
the world itself is math?
Right. It's kind of like
Yeah.
saying that the blueprint for a house isn't just a representation of the house. It's
Right.
what the house is made of.
Oh, okay. I like that.
It's like the fundamental building block.
Yeah, that's kind of blowing my mind already. But,
Yeah.
Artificially Aware points out this isn't some new age idea.
Right.
Like Pythagoras and Leibniz were already kind of exploring these concepts centuries ago.
Yeah, absolutely.
So-
These ideas have been simmering in philosophy and mathematics for a long time.
But what's cool is
Yeah.
how modern science, particularly things like quantum mechanics,
Right.
are kind of breathing new life into these ancient concepts.
Yeah, it's like they're almost coming full circle.
Yeah, totally.
So speaking of evidence, From Pawn to Player suggests that we can actually see this idea
Okay.
like reflected in nature.
Oh, interesting. Okay.
Like think about the golden ratio
Right.
and the Fibonacci sequence.
Yeah.
We see these mathematical principles woven into everything.
Oh, wow.
From like seashells and flowers
Yeah.
to hurricanes and galaxies.
That's amazing.
Yeah, it's not just like pretty patterns.
Right.
They're pointing to like an underlying mathematical order
Yeah.
that governs the universe.
That's so cool.
Okay, so we've got ancient philosophers,
Yeah.
seashells, galaxies, all kind of hinting at this idea.
Yeah.
But you mentioned quantum mechanics.
Right.
How does that fit in?
So quantum mechanics is all about how the universe operates at like the smallest level. And what's fascinating is that it reveals a universe that's operating on like fundamentally mathematical principles.
Okay.
So it's like there's this cosmic code written in the language of math
Whoa.
that's governing everything from the tiniest particles to the largest structures in the cosmos.
Okay, so instead of just using math to describe what we observe, we're saying that math is like the underlying reality.
Exactly.
It's like the difference between describing a cake
Right.
and actually like knowing the recipe.
Exactly.
You get it.
I think I'm starting to get it.
Okay, good.
So one of the things that From Pawn to Player focuses on is how this idea could impact us personally.
Okay.
It introduces this idea of humans being thinking math.
Oh, thinking math.
Yeah.
What does that even mean?
Yeah. Are we just like walking calculators or something?
That's a good question.
Yeah.
Not exactly. What it means is that if the universe is fundamentally mathematical,
Right.
and we're part of the universe,
then we too are expressions of this underlying mathematical structure.
okay.
Our thoughts, our feelings, our actions,
Yeah.
they're all kind of part of this grand mathematical equation.
So in a way, we're not just using math to understand the world.
Right.
We are math understanding itself.
Exactly.
Whoa.
Yeah. It's a pretty wild thought.
That's a really wild thought.
Yeah.
And From Pawn to Player suggests that grasping this concept can actually help us make better choices in life.
Oh, that's interesting.
Yeah.
So it's like,
yeah.
if we can start to see the underlying mathematical logic in our lives, perhaps we can approach decision-making with more clarity and reason.
Okay.
It's like upgrading our operating system.
Right.
From just like emotional impulses to something more grounded and logical.
I like that a lot.
Yeah.
So that kind of leads us to what might be the most mind-blowing question of all.
Okay, hit me.
And artificially aware really dives into this. What does this whole idea mean for consciousness? Like, if everything, including us, is ultimately mathematical, what does that say about, like, our thoughts, our feelings, our experiences, like everything that makes us conscious beings?
That's a great question.
Right.
And, some proponents of ontological mathematics suggest that consciousness itself might arise from these complex mathematical relationships.
Okay, hold on. Are we saying that consciousness is just like a really complex math problem?
It's a radical idea.
Yeah.
But that's what some are suggesting.
Okay.
And it raises huge questions.
Oh, yeah.
About the nature of reality, the potential of AI, and what it means to be human in a universe governed by mathematical laws.
Okay. My brain is officially starting to hurt.
I feel that.
And we haven't even gotten into the really technical stuff yet.
I know, right? We're just getting started.
All right.
Buckle up.
Sapientia et Veritas is where we're going to dive deep into the nitty-gritty math and philosophy.
I'm ready.
Okay, so Sapientia et Veritas starts off by talking about Euler's formula.
Oh, yeah. Euler's formula.
What's so special about this formula?
Well, Euler's formula is considered like a crown jewel of mathematics.
Okay.
It's this surprisingly simple equation that connects these seemingly disparate mathematical concepts.
Right.
Like pi imaginary numbers. And exponential functions.
Okay, so it's bringing together a lot of different things.
Yeah, it was like a unifying theory.
Yeah, and the video even quotes Richard Feynman.
Oh, yeah.
Calling it our jewel.
It's beautiful.
Which I thought was a nice touch because it really highlights how important and beautiful this formula is considered to be.
Yeah, it's like a work of art.
Yeah, but it's not just like a pretty equation, right? It actually has like implications for understanding the nature of reality.
Yeah, exactly. Euler's formula isn't just some neat mathematical trick.
Okay.
It suggests this profound interconnectedness between different aspects of the universe, all kind of woven together by this language of mathematics.
So this like seemingly simple formula is actually hinting at like a much deeper truth.
Totally.
About the mathematical underpinnings of reality.
Yeah, it's like a Rosetta Stone for decoding the universe.
Oh, I love that.
Right.
Okay, so that brings us to another really interesting concept from Sapientia et Veritas.
Okay, what's that?
Oh, monads.
Oh, monads. Okay, I'm ready for another brain twister.
I know, right?
How do they fit into all of this?
So monads are these fundamental indivisible units of reality.
Okay.
A concept developed by Leibniz.
Okay.
So think of them like tiny self-contained universes.
Okay.
Each one is like a perfect reflection of the whole.
Whoa, so every single monad, no matter how tiny, contains like the entirety of the universe within it.
That's the idea.
That's wild.
Yeah, and if we connect this back to ontological mathematics, if reality is fundamentally mathematical, maybe these monads, these building blocks of existence, are themselves mathematical entities.
Oh.
So each monad could be like a unique mathematical expression.
Right.
And together they kind of create this intricate tapestry of the cosmos.
That's beautiful.
Okay, so I'm starting to see how these pieces fit together.
Me too.
We've got this idea that math is like the fundamental reality, and we're seeing potential evidence for this in nature, quantum mechanics, and these like incredibly elegant mathematical concepts, like Euler's formula and monads.
It's a compelling idea.
Right.
The idea that the universe isn't just describable by math, but actually is math at its core.
Yeah, but of course it's not without its critics.
True.
Artificially Aware does mention that there are some who kind of push back against this idea.
Yeah, of course.
So what are some of the main criticisms?
Well, one of the biggest criticisms is that reducing reality to pure mathematics might be oversimplifying things.
Okay.
Like, can math really account for the richness and complexity of the world? Right. Especially things like consciousness, emotions, and subjective experience.
Right. It's like trying to explain the taste of chocolate by describing its chemical composition.
Exactly.
Yeah, you might get the technical details right, but...
You're missing the essence.
Yeah, you're missing the essence of the experience.
Exactly.
And some critics argue that while math is incredibly powerful for describing the universe, it's not clear if it can account for everything.
Right.
There might be aspects of reality that go beyond the reach of mathematical description.
I agree.
So ontological mathematics gives us this fascinating new lens to view the universe through.
It does.
But it's important to acknowledge that there are still open questions
of course,
and areas of debate.
Absolutely.
So we've covered a lot of ground in this first part of our deep dive into ontological mathematics.
Yeah.
We've explored the core idea that math might be the fundamental reality of the universe.
We did.
We've looked at potential evidence from nature and quantum mechanics, and even delved into some pretty mind-bending mathematical concepts.
Mind-bending is right.
Like Euler's formula and monads.
It's a lot to take in.
And we've also acknowledged that there are challenges and criticisms to this idea, which is important for fostering healthy intellectual debate.
Absolutely. Healthy debate is key.
But we're not done yet.
Oh, there's more.
In the next part,
okay,
we're going to explore the implications of ontological mathematics for some even bigger questions, like
what?
Like free will, the nature of time, and the possibility of multiple universes.
All right, I'm ready for part 2.
So stay tuned because things are about to get even more mind-bending.
Can't wait.
Okay, so last time we dove headfirst into this mind-bending world of ontological mathematics.
Yeah.
Exploring this idea that math might not just describe reality, but actually be reality.
It's a wild concept.
Are you still with me?
I'm hanging on.
We covered a lot of ground.
Yeah.
From ancient philosophers to quantum mechanics.
Right.
And it only gets more intriguing from here.
I can't wait.
We left off talking about how even consciousness itself could be like a product of these mathematical processes. But artificially aware kind of takes it even further.
Okay.
And starts exploring how this whole mathematical universe idea might impact our understanding of some pretty massive concepts.
Okay.
So, what does it mean for free will?
Right.
If everything is ultimately governed by these mathematical laws?
That's the big question, isn't it?
Yeah. Are we just robots following a predetermined script?
Yeah.
Does this mean we don't really have any choice in our actions?
Yeah. You start to wonder, is that gut feeling we all rely on, is that just a mathematical calculation that we haven't consciously processed yet?
It makes you question everything.
Totally. It's a question that's been around for centuries. Yeah. Philosophers and scientists, determinism versus free will.
Yeah.
And this ontological mathematics thing.
Right.
It definitely adds fuel to that fire.
From pawn to player, though, it seems to argue that we do have a degree of free will.
Interesting.
Even within this mathematical framework.
Okay.
It talks about using logic and reason to make better choices, which suggests that we're not just passively being pushed around by equations.
Yeah, it's not like we're just puppets,
Right, exactly.
Yeah. So what's their take?
It seems to be saying that understanding these mathematical principles could actually give us more control over our lives.
Oh, interesting.
Not less.
Okay.
It's like we're not simply passengers on this mathematical train.
Yeah.
We can actually learn to drive it.
I like that.
Okay.
Okay. But what about time?
Oh, time. Yeah.
Sapientia et veritas briefly mentions how ontological mathematics might challenge our typical understanding of time as this linear progression.
Yeah, past, present, future.
From past to present to future.
Totally. So how does it challenge that?
If reality is fundamentally mathematical, then time as we perceive it might just be another dimension within this mathematical structure.
Interesting.
Not necessarily a straightforward line from point A to point B.
So are we talking time travel?
Yeah. Are we talking parallel universes?
What does it even mean?
Yeah. What does it mean for time to be a dimension in a mathematical sense?
It's a lot. Right. It's hard to kind of wrap our heads around. But think of it this way. Instead of like a river flowing in one direction, time might be more like a vast ocean. Where the past, present, and future all exist simultaneously.
Whoa.
Yeah.
So it's not that the past is gone.
Right.
And the future hasn't happened yet.
Exactly.
It's more like all moments in time.
They're always present.
It's all happening at once.
Within this mathematical structure.
Yeah, that's how some proponents of ontological mathematics might explain it.
Okay.
This actually aligns with some ideas in physics.
Okay.
Like the concept of a block universe.
Right.
Where the past and the future are just as real and concrete as the present moment.
So maybe our perception of time moving forward is just an illusion.
Maybe.
A product of how our brains
are
wired to experience this mathematical reality.
Possibly.
And artificially aware takes this even a step further by suggesting that this mathematical framework could even allow for multiple universes.
Multiple universes. Okay.
Yeah.
Are we talking like parallel realities?
Parallel reality.
Alternate timelines.
The whole sci-fi shebang.
Okay.
So
lay it on me.
If the universe is ultimately a mathematical structure, then theoretically there could be other mathematical structures, other universes existing right alongside our own, each one governed by its own unique set of mathematical principles, potentially resulting in vastly different physical laws and realities.
Okay, so there could be a universe where gravity works differently.
Yeah.
Time runs backward. And the laws of physics are completely different from our own.
It's mind-boggling
to
imagine. And if we could somehow access these other universes, what kind of incredible discoveries
I know. What would we find?
might be waiting for us?
Yeah, universes teeming with life, maybe.
Right.
Universes where consciousness has evolved in ways we can't even fathom.
Or universes that are totally barren and devoid of any complexity.
It's crazy to think about.
It's like ontological mathematics just opens up this infinite playground of potential realities.
Yeah.
It's enough to make your head spin, but that's part of the beauty of it.
Yeah.
It challenges us to really question our assumptions and embrace the vastness of the unknown.
I love that.
Okay. We've talked about free will, time as a dimension, even multiple universes.
Yeah.
What other implications does ontological mathematics have for our understanding of, well, everything?
Well, Sapientia et Veritas suggests that it might hold the key to solving some of the biggest mysteries in physics.
Like what?
Like the nature of dark matter and dark energy.
Right, the stuff that makes up the majority of the universe.
Right.
But we have no idea what it actually is.
Exactly. But if the universe is truly a mathematical structure, then perhaps there are mathematical principles we haven't discovered yet that can explain the behavior of these things.
So instead of looking for new particles or exotic forces, maybe the answer is hidden
within the math itself.
It could be.
Like there's an equation out there that explains it all.
Yeah.
We just haven't figured it out yet.
We just haven't cracked the code.
And who knows?
Yeah.
What other breakthroughs could come from thinking this way?
Yeah, it could revolutionize cosmology, quantum physics.
Computer science.
Yeah, even computer science.
It could even change how we understand the origin of the universe itself.
How so?
If the universe is fundamentally mathematical, then perhaps the Big Bang was, in a sense, a mathematical event.
Oh, wow.
The moment that this structure emerged from a singularity.
So instead of just like a random explosion, it was like this moment of profound mathematical elegance.
I like that image a lot better.
Me too.
So it was like a perfectly orchestrated symphony of numbers.
Yeah.
Giving rise to the cosmos as we know it.
It's a beautiful thought.
It is a beautiful thought.
But this is all incredibly fascinating.
It is.
But I have to admit, it's a lot to wrap my head around.
I know, right?
How do we even begin to process these mind-bending concepts and make them relevant to our lives?
Well, artificially aware reminds us to approach these ideas with curiosity.
Right.
An open mind.
Yeah.
And to really embrace the mystery and wonder of it all.
Right. It's not about having all the answers.
Exactly.
It's about being open to the possibility that there's a lot more to reality than we currently understand.
We're just scratching the surface.
Yeah. And it's important to remember that ontological mathematics, it's still a relatively new and developing field.
It is.
There's a lot more to be explored and understood.
For sure.
So where do we go from here?
Yeah, that's a good question.
What's the next step in this exploration of math as the foundation of everything?
Well, for one, we need to keep asking questions. Keep pushing the boundaries of our understanding.
And be willing to let go of our old assumptions.
Yes.
And embrace new ways of thinking about the universe and our place within it.
Exactly.
The exploration of this concept is just beginning.
Yeah.
And it has the potential to change everything.
It really does.
So to all you listeners out there,
yeah,
what's resonating with you?
What are your thoughts?
What are your biggest questions about this mathematical universe idea?
Right.
What implications are you grappling with?
Yeah, let us know.
We'll be back.
We will.
For one more dive.
Yes.
To try and wrap our heads around all of this.
Okay.
But for now, let these ideas simmer.
Yeah.
The universe might just be waiting.
It might be.
For us to decode its mathematical secrets.
Who knows?
Welcome back, everyone. It's part 3 of our deep dive into this crazy concept.
Ontological mathematics.
Yeah, ontological mathematics.
We've been on quite a journey.
It's been a lot.
Exploring this idea that math might not just describe reality.
Yeah.
But actually be reality.
It gets wild.
It is a mind-bending idea.
Yeah, we've gone from questioning if the universe just, speaks in numbers.
Yeah.
To considering if it is numbers.
Like a symphony.
A symphony of mathematics.
Composing reality itself.
I love that.
It's quite poetic.
So we've wrestled with some pretty massive questions.
We have.
Like free will in a predetermined universe.
Yeah.
Time as a dimension. Even the possibility of a whole multiverse out there.
It's a lot to process.
It really is a lot to process.
Yeah.
So now as we wrap up this deep dive, I'm curious, what does it all mean? Where do we even go from here with this whole idea?
That's the question, isn't it?
Yeah.
Sapientia et Veritas really emphasizes the beauty and elegance of math.
Okay.
And it kind of suggests that this beauty might be a reflection of a deeper truth about the universe.
Yeah, I think that's what's so captivating about this whole concept.
Yeah.
It's not just some dry academic theory.
Right.
It's about recognizing this incredible order and beauty.
It is.
Woven into the fabric of reality.
It's like we're realizing that we're living inside a masterpiece.
Yeah.
This intricate and awe-inspiring work of art.
Yeah.
That's created from pure mathematics.
It's pretty amazing.
It's humbling.
Yeah, and inspiring.
Yeah.
Absolutely.
Yeah.
So it makes you feel connected to something much larger than yourself, like part of this grand cosmic dance of numbers.
It's beautiful.
But I also keep thinking back to From Pawn to Player and how it focuses on the practical implications of all of this.
Right.
The video argues that understanding ontological mathematics can actually empower us.
Right.
To make better choices in our lives.
Yeah, if we can grasp that idea that we're fundamentally mathematical beings, maybe we can start to approach life with a new level of clarity and intention.
It's almost like we're upgrading our decision-making process. From just reacting emotionally to thinking more strategically, seeing the underlying patterns and logic in our choices.
Yeah, and that could lead to a greater sense of agency and purpose.
Right.
Right? Recognizing that we're not just reacting to circumstances, but actively shaping our reality within this mathematical framework.
It's a powerful idea.
It is.
And I think it connects to what Sapientia et Veritas was saying about the beauty of math reflecting a deeper truth.
Yeah.
Maybe that truth isn't just out there in the cosmos. It's also within us, guiding our actions and shaping our destinies.
It's an interesting thought.
It is an interesting thought.
Okay.
So this leads to an even bigger question.
Okay.
If this universe is a mathematical structure, could there be a mind behind the math?
Whoa.
Like a consciousness that created it all?
A cosmic mathematician designing the universe.
Yeah, it's pretty wild.
Is a mind-blowing concept.
It is a mind-blowing concept.
And while ontological mathematics itself doesn't necessarily provide any definitive answers to those kinds of questions, it certainly opens up a whole new realm of possibilities to consider.
So it's like this whole deep dive has been about expanding our perspectives, challenging our assumptions, and realizing that there might be much more to reality than we initially thought.
We've only just begun to explore.
Yeah, and even if we don't walk away with all the answers, hopefully we've sparked some curiosity, ignited some imaginations.
It's a new idea.
And maybe even inspired you to look at the world with a fresh perspective.
That's what we hope for.
So as we wrap up this episode, I'd like to ask you, the listener, what's standing out to you in all of this?
What resonates with you? What questions are swirling in your mind now?
Yeah, because in the end, ontological mathematics isn't just about equations and theories. It's about understanding our place in this grand, mysterious, and perhaps ultimately mathematical universe.
It's a big universe out there.
It is a big universe out there.
Keep those questions coming.
Keep exploring.
And who knows what other mind-blowing discoveries await.
Yeah, so thanks for joining us on this deep dive.
Thanks, everybody.
Into ontological mathematics. Until next time, keep seeking knowledge.
Keep questioning everything.
Keep looking for those hidden patterns in the fabric of reality.
Absolutely.